All right. Lesson 8.2, angles. An angle, ladies and gentlemen, an angle is two rays that have a common endpoint. That is the mathematical term for an angle, is two rays that have the same endpoint. Something like this. There's an endpoint. There's a ray, and there's a ray. Those two rays that have the common endpoint form what is called an angle, right? It's an angle. Here's the deal. Here's the deal. The endpoint where the two rays meet, where the endpoint where the two rays meet, that is called the vertex. The vertex is the intersection of two sides of an angle or a figure, right? If I have a triangle, right, that's a vertex, that's a vertex, that's a vertex. Where we have in either in an angle or in any like figure where two lines or rays meet, that is called a vertex. Okay? This is all stuff that you're going to have to do on your project. Yes, vertex is one of the words. Now, if you were going to be on your project, people, and you were going to be showing me that you knew what a vertex was, and you drew this, and you said that's a vertex, I would say no. I would mark it wrong. That does not show me that you know what a vertex is. What should you do? What should you do? Sladen. I would actually just point an arrow right to there, and all of a sudden, like, oh yeah, they get it. They know where the vertex is. Does that make sense? Right? All stuff that's important that you're showing me by using drawings that you know how to define those terms. That's what that project's about. Anyway, here's the deal. You measure angles in what's called degrees. Degrees. Okay, you measure angles in what is called degrees. Here's the thing. A very common angle is when it forms a right angle, like the end of a book or the end of the table or the corners of this room, right? The corners of a square or a rectangle. Those things form a 90-degree angle. A 90-degree angle. Okay? Whenever there are, whenever one's like perfectly flat and one's straight up and down, whenever you have like something like this, those guys are 90-degree angles. Do you know how, first of all, a 90-degree angle, what's another name for a 90-degree angle? A right angle. And you write a right angle by putting a little box there. That tells everyone that that angle right there is a right angle. Does that make sense? If you just drew it like this and you left it like that, I don't know that you really know that it's a right angle, right? Maybe it's not 90 degrees. Maybe it's 89 or 91 degrees, right? Since I'm not perfect and I'm not going to be able to draw it perfect, if I want you to know that what I meant to draw was a 90-degree angle, what am I going to do? I'm going to put that little box, right? Put that little box there and all of a sudden, oh, I get it. He tried to draw a 90-degree angle. Make sense? Does that make sense? Here's the deal. The angles that are, here's our 90-degree angle, right? Angles that are skinnier than 90 degrees are called acute angles, and you can kind of think of it like that. Oh, look, it's so cute. It's small, right? Angles that are smaller than 90 degrees are acute angles. Angles that are bigger than 90 degrees, do you see how that's bigger? That's called obtuse. Somebody who is extraordinarily fat, what do they call that? That is called obese. O-B-E-S-E. Somebody who is very fat, one of the names is obese. Obtuse. A fat angle. Right? A fat angle. If it's a small angle, it's acute. It's acute angle. Does that make sense? Oh, how cute. Does that make sense? I'm just giving you these words to help you remember the difference between acute and obtuse. There's another angle that does this right here. That's actually an angle.
Yeah.
It's called a straight angle. Okay? A line is a straight angle, right? I have a question. Look here. If this angle here is 90 degrees, if it's 90 degrees, how much is this angle, do you think? 90. Right? Then the other side would also be 90. Do you agree? Does that make sense?
Yeah.
So then, if that's true, how many degrees is that straight angle? The whole thing. The whole thing is 180 degrees, right? 180 degrees. Straight angles are 180. Right angles are how many degrees? 90. Acute angles are less than 90 degrees, and obtuse angles are bigger than 90 degrees. Does that make sense? Make sense? Okay. I'm going to, here in a minute, give you guys, I'm going to lend you guys some protractors. I'm going to show you really quick what a protractor looks like. Protractor is a half circle. Looks like this. Okay? And on this protractor, it will have little marks like this. Here's the deal. This right here would say 10. This would say 170. This would say 20. This will say 160. This will say 30. This will say 150. This will say 40. This will say 140. This will say 50. This will say 130. This will say 60. This will say 120. This will say 70. This will say 110. This will say 80. This will say 100. This one will say 90. And this one will say 90. And it will keep going all the way around. Does that make sense? It will keep doing that. On your protractor, it will have both. So here's the deal. This is what you do. You take your protractor. I'm going to show you. Here's the protractor. And you lay this thing down so that the bottom of the protractor, here's the deal. Let's just say that I had an angle here. Say I had an angle here like this. What you're going to do is on your protractor, there's another little part here, your protractor that goes like this. And there's usually a little dot that's down here in the bottom of the protractor. That's where you're going to put the vertex of the angle. Okay? And you're going to take one of the lines of the angle and you're going to run it right along the base of the protractor. Okay? You're going to lay this protractor right on top, kind of like I've got it done down here. Does that make sense? I'm going to lay the protractor right on top so that that little dot that's right here is right at the vertex. And you're going to line that line, one of the sides of the angle, along the base of the protractor. And you're going to look at this. First of all, can you tell me something about this angle without anything else? Forget the numbers. What can you tell me about this angle? It's acute. How do you know it's acute? Because it's smaller than a right angle, right? It's smaller than 90. You know it's acute. So listen, did you hear that? You know it's an acute angle. So when I look up over here, and I look up on my protractor, and I see that it has crossed both 50 and 130. See how it's crossed both? How many degrees is this angle really? Is it 50 or is it 130? Why is it 50 and not 130? Why? Because it's an acute angle. We already decided that this thing is what? Smaller than 90. Do you understand what I'm saying? What happens here, people, is that sometimes you get a big angle like this. Oh, here, hold on. Look at the angle. Is that, what do you know about the angle? It's obtuse. So that means that it is bigger than 90. We're looking at the angle. We see that it's obtuse. It's bigger than 90 degrees. So when it goes through both the 50 and the 130, how many degrees is that angle? Why is it 130? Why not 50? Because we've already decided that it is obtuse. Does that make sense? You might need this part of the protractor for an acute angle, or you might need it for an obtuse angle. And that's why there's both there. You just have to decide which one is it. Is my angle obtuse, or is it acute? Does that make sense? I have another question for you here then. Let's take a look at this. You tell me something about my angle here. Here, hold on. Can you tell me, just by looking at that, roughly how many degrees that angle is going to be? Can you tell me just by looking about roughly whether or not, first of all, tell me something you know about it. What do you know about that angle? What do you know about that angle? It's acute. Okay, so it's going to be less than 90. All right, can you tell me, just give me a ballpark? How many degrees is that going to be? How many? 30. Yeah, it's going to be, here's the deal. Would you say that's about halfway between a 90 degrees? Would you agree that it's about halfway between a 90 degree angle and 0? So then what's half of 90? 45. I would say that's about a 45 degree angle, okay? I agree. You agree? Tell me this. So we're going to agree that this is roughly 45 degrees. Oops. That this right here, that angle is roughly 45 degrees. Give or take a few degrees, right? Okay. What about this? How many degrees is that angle? Oh, right. Does the length of the legs have anything to do with the size of the angle? No. Remember, they're raised. So how far out is this? How far does that thing go?
Forever.
Oh, forever. And how far does this one go? Forever. The size of the angle, the number of degrees of the angle has nothing to do with how long the ray I'm drawing. It's how big the mouth is, right? It's how big the angle is. That was very good. It doesn't matter how long the legs are. Make sense? Makes sense? Okay. Wow. Here's something else. Can anybody tell me, what did I just create here? What did I just create? I created a certain type of lines, a certain set of lines. What is it called? They are intersecting, for sure. Awesome. But these are even more specific than that. Do you know?
I was going to say 4 right angles.
Right, that's true. What are they called? When you've got 2 lines that create 4 right angles, those lines are called perpendicular. Whenever you have 2 lines that cross, that form 4 90-degree angles, these lines, the lines themselves, are called perpendicular. Perpendicular lines cross so that they create a perfect plus sign or a perfect cross. 4 90-degree angles. What about 2 lines that never touch? What about, we talked about this yesterday. 2 lines that never touch are called parallel. So you got 2 different, there's 2 very special types of lines. Lines that never touch, parallel, if they're on the same plane. 2 lines that are on the same plane that touch so that they form 4 90-degree angles. Those lines are called perpendicular. Right? Perpendicular. If I just have 2 lines that do this, though, first of all, are those perpendicular lines? No. How do you know they're not perpendicular? Because is that angle a right angle? No, that angle is obtuse. Right? And that means that this angle here is acute. Smaller than 90, right? If there's an obtuse or an acute angle, then certainly there can't be four 90-degree angles, right? If there were four 90-degree angles, they would all have the same angle, and they would all be like the end of a book, right? Or the corner of this room. Make sense? Make sense? Okay. Let me see what else they ask so that I can... Okay, we're still going to do that. I'll do that here in a second. Okay. If I was going to ask you to draw for me or construct for me some lines with certain degrees, Jonathan, sit up. If I was going to ask you to draw for me an angle of a certain degree, say I was going to ask you to draw for me a 30-degree angle, let me show you what you do. You first need to get a ruler out, or you can even use the bottom of your protractor, and you create yourself a line, one line. Now, you choose the end point on that line, and you lay your protractor right where they're, you know what I'm talking about? And at the end of your line, you put that little dot that's on the protractor, and you find the 30-degree point. Now listen, there's going to be a 30 degrees over here, and there's going to be a 30 degrees over here. It's going to say 30 and 150 and 30 and 150. Which one of those am I going to aim at? The one that's on the... Am I going to aim at the one that's right here? Am I going to draw my graph so that it's like this? Why not? Is that a 30-degree angle? No, how many degree angle is that? 150. How do you know? It went right through the 30? Because it's obtuse. So then when you do it, you're going to go over here because that's clearly acute and it goes right through the 30. Remember, there's two 30s to look at, right? So when you do it, when you construct this, you're actually going to put a dot right at the 30. You know what I'm saying? Put a dot. Take up your protractor. Lay it down so that it's like this, and then just draw your line. Does that make sense? Does that make sense? That's a 30-degree angle. You just measured it. Question, Donovan?
What if we don't have a character whatever?
A protractor?
Yeah.
I'm going to give you one.
Oh, you are. Nice.
Well, I'm going to lend you one. Yeah. You know what lend means? Okay, let's try this. Let's try this. I have another question. What if I draw you this? Little tiny thing. And your protractor is this big. What are you going to need to do? What are you going to need to do? What? Yeah, you're going to need to go back and make these lines longer, and then you're fine. Does that make sense? You're just going to need to extend the lines so that you can see where you're drawing. Does that make sense? Make sense? Okay. Go ahead and look at page 367. Look on page 367. The very bottom where it says use a protractor to measure the angle at the left. You see that little angle at the left? The little tiny angle there. Now, I won't let you draw in the book, so you are going to have to kind of guesstimate. Right? You're going to have to guesstimate here. I want you to create for me a 20-degree angle, a 120-degree angle, and a 170-degree angle. I want all three of those right now. Create for me all three of those right now. 3 separate angles. I want you to create them for me right now. All right, I'm going to let you guys start your homework. Here's the deal. You guys have constructed enough angles for me right now for me to be confident you know how to do this. I'm going to give you homework tonight that does not require you to have a protractor. But tomorrow when you come into class, we're going to take a quiz, and I am going to have you create some angles for me. Does that make sense? Does that make sense?
So, can I borrow this
No. Anyway, here's the homework. It says 6 to 24. Okay, I want you to do, this is going to be different than what it says on RunWeb. You're going to do I'll change it. Yep. So it's 9 to 15 even? All, right? 9 to 15 all and 30 and 31. Makes sense? That's what we're doing today. I'll change it on RunWeb right now.